So with an equation like this, I know that when the bases are the same, I add the exponents. 3 plus x. The equal sign stays, equals 7. So you set the exponents equal. And then you just solve for x, which is going to be me doing minus 3 and x equals 4. So that's easy. So today, the bases are not going to match, but we're going to make them match. We have our list of perfect squares here. 1, 4, 9, 16, 25, 36, 49. Those are all the perfect squares. So, here we go. 4 is obviously 2 squared. 9 is going to be 3 squared. 27 would be what? It's not to the power of 2. What's 27? Yeah. 3 cubed. Thanks, Shiv. So, when the bases don't match, change them. So you have to find a really small number that makes 4. What makes 4? We did it already up above. 4 is the same as 2 squared. So I'm going to do this. 2 squared, because that's 4, and then the x still has to stay in the exponent, equals, and then 2 to the 3x minus 6. So I'm looking at the bases. They're both 2's. I'm going to set the exponents equal to each other. 2x, so 2 times x, equals 3x minus 6. So set the exponents equal. Set x equal. 2x equals 3x minus 6. And then you go. Then you solve. Get the x's together, yeah? Negative x equals negative 6. X equals 6. So I'm setting the exponents equal to each other, and I'm solving the equation. So first, make the bases match. Make the bases match. Set exponents equal. 2 to the 3m equals, okay, what do I do instead of 4? What do I replace a 4 with? Instead of 4, what do I write? Yeah. 2 squared. And hi, good to see you. 2 squared to the negative 12. Okay. The bases are the same. They're both 2's. I'm going to set the exponents equal. 3m equals negative 24. And solve for m. Right? Divided by 3. M equals negative 8. Okay, and you're done. So, again, what does 27 become? How do I write 27? What do I replace it with? Someone new. Yes. Emily. 3 cubed. 3 cubed to the x minus 4 equals 3 to the 2x minus 6. And the bases are the same. They're both 2's. Set the exponents equal. This is a 3 times x and a 3 times negative 4. I have to multiply 3 by both of those things. Distributive property. 3x minus 12 equals 2x minus 6. and solve for x. X minus 12 equals negative 6. Add 12. X equals 6. All right. Ooh, 1 over 125. Well, that is a fraction. 125 is at the bottom. 125 is right here. How am I going to get a number in the denominator, though? How does that ever happen? That a number drops down and the reciprocal happens. Yeah, a negative exponent. 125 is made from 5 cubed. But if I did 5 to the negative third power, that would be 1 over 125. So I'm kind of like working backwards. I'm going to do 5 to the negative third instead of 1 over 125. So 1 over 25 would be what? Just 25. Find 25 on the board. So if it's 1 over 25, that's going to be 1 over 5. I'm sorry, it's going to be 5 to the negative second. Negative x over 3 minus 2. This is still distributive property. Well, on the right side, it's going to be distributive property. I'm going to multiply negative 3 times negative x over 2. The 5s are both the same. The bases match up. So I'm going to do, what is 3 times negative x over 2? What is that? It's two fractions being multiplied. We did fractions earlier last week. What do I do? Multiply straight across. What do I get? Straight across, what do I get? Okay, we can just sit here and wait. I will literally wait for you. Somebody new. What is this number when you multiply straight across? Yes. Thank you. 3x over 2. 3x over 2 equals, now this negative 2 needs to be multiplied by both of those. So I wrote it over here on the left. Negative 2 times negative x over 3, and then negative 2 times negative 2. Distributive property. Two x over 3 plus 4. All right, clearing fractions. 3x over 2 equals 2x over 3 plus 4. I don't want fractions in a math problem. I want to get rid of the denominator. The denominators are 2 and 3. So what is a common denominator of 2 and 3? 6. Someone said that is right. So I'm going to do everything times 6 times 6 times 6. The reason I'm using 6 is because then the 2 cancels. 2 goes into 6 3 times. 3 goes into 6 twice. So 3 times 3x, 9x. 2 times 2x, 4x, plus 4 times 6, 24. And this is not hard at all. So, subtract 4x. 5x equals 24, and we have a fraction answer, which is totally fine. (24 over 5). That was a hard problem, huh? There was a lot involved in that one. Okay. So with these, I want to do example 3. Okay. Using the quotient of powers property to solve equations with rational exponents. Terrarium A and B are cubes. The side length of terrarium A is twice the side length of terrarium B. So it's like double the size, right? So I need to write down, if it's twice the size, the volume equals length times width times height. Yeah? Length times width times height. And they're all the same size. Since they're all the same size, the side length of terrarium A is twice that of B. They're double the size. So here's the equation I'm going to write. One of the volumes is, so we're going to write a proportion. Oh. So I'm going to get 2 to the x. One of the sides is 2 to the x, or the volume is 2 to the x. Now, length times width times height means I need to multiply 3 things together. Length times width times height. They're all the same number, though, because it's a cube. Yes? So, I'm going to raise this to the 1/3 power because I don't know what the 3 numbers are. So, it's like the inverse of 3, the reciprocal of 3. Length times width times height. 3 numbers multiplied. Then I'm going to divide that by the other volume is 2. 2 to the 1/3. So this becomes 2 to the x over 3 over 2 to the 1/3. And then I can say that like these x3 minus 1/3, because I'm subtracting. Remember with division I subtract? So I'm going to leave it like this just so we can see where we're at. Okay, we're just going to set it up. And we'll stop there. I will press stop on the record.